Customer Council webinar. My name is Tracy Berardi, and I am Program Manager of the CSCC. The CSCC has just published the Practical Guide to Platform as a Service, which is a white paper that contains an informative and in-depth overview of the Platform as a Service cloud service category, including definition, examples, important considerations, and best practices. And today I am joined by contributors John Megan and Mike Edwards, who will introduce this paper and share advice for using PaaS services. If you would like to download the white paper or the presentation file from today, there is a link in the chat box that's in the GoToWebinar toolbar. And also, following the webinar, we will post the presentation file and a recording to our website, which is cloud-council.org. You can see that here on the title slide. We do encourage questions, and we'll have some time at the end of the presentation for Q&A. If you'd like to pose a question, you can use the questions box in the GoToWebinar toolbar. And with that brief introduction, I'll turn it over to you, John. Thank you.
Thanks, Tracy. I'd like to mention that in addition to Mike and myself, there were 7 or 8 additional folks who contribute significantly to the paper. You'll find their names in the acknowledgement section of the document. Mike and I are representing the entire team on this call. I do encourage everyone to download and review the paper if you haven't done so already. A direct link is provided at the bottom of this first title chart. Before we jump into the details of the white paper, I'd like to provide just a little background on the CSCC itself. So Tracy, yes, thanks. So the CSCC is a customer advocacy organization that provides guidance and levies requirements on cloud standards bodies. And to that end, the council develops collateral-like best practices, use cases, does some standard gaps analysis, etc. Over the past 4.5 years, the council has grown to over 550 member companies. The collateral that the CSCC has delivered since its inception is highlighted on this chart. And at the bottom is actually the list of projects the CSCC has been working on this year, including the Practical Guide to Platform as a Service, which is the focus of today's talk. And so I'd certainly encourage folks who are interested in any of these topics to consider joining the appropriate working group and engaging either as a contributor or a reviewer. The time commitment is pretty minimal, and I can tell you that everyone I've worked with on a project has had a very positive experience. So Tracy, let's move to the next chart. So the remainder of the presentation focuses specifically on the Practical Guide to PaaS. The table of contents for the paper is actually included here since it provides a good overview of the flow of today's presentation. So PaaS is certainly one of the most dynamic areas of cloud computing, and there's certainly lots of confusion in the market about what PaaS means and specifically what capabilities should be expected of a PaaS offering. So the first part of the presentation is going to focus on setting the context for PaaS. So we'll provide, a clear description of the characteristics, capabilities, and benefits of PaaS, along with a discussion on governance and business considerations that need to be taken into account when using a PaaS offering. The next part of the presentation provides specific guidance to cloud customers for acquiring and using PaaS services. So this really is the guts of both the guide and the presentation. So in this section, we'll examine the types of applications that are best suited to PaaS platforms. We will discuss the architectural styles involved and we'll take a closer look at the development and operations techniques that are most appropriate. So the recommendations and best practices for using PaaS that are contained in the guide and included in this presentation are going to cut across a wide range of disciplines, including architecture, development processes, integration, development, and operations. In addition, differences with traditional app development and delivery are highlighted, since the biggest gains for enterprises in many cases result from the adoption of newer, more efficient, and less error-prone techniques for creating, testing, and deploying applications. And so all of these areas will be covered in more detail as we go through the presentation. So with that as some background, what I'd like to do now is turn it over to Mike Edwards, who will take us through the remainder of the presentation. Mike, over to you.
Thanks for a great introduction, John. So on slide 4, let's start by trying to put platform as service into the overall context of cloud computing. This tries to get rid of some of that confusion that we've seen people in the marketplace with PaaS and what it is and what it does. So on this chart, what we're looking at is a variety of ways in which applications get deployed. And on the left-hand side, all in blue there, are the traditional way of deploying and running an application on premises within your own enterprise. And in that case, you've got the hardware at the bottom, the servers, the storage, the networking, any virtualization, any operating systems you're going to use, and then the middleware stack, the runtimes you're going to use, the data, and the applications. And you're responsible for all of that stuff if you're going to run it on premises. Now, when we're looking at cloud computing, the 3 stacks further right, we're looking at effectively getting some or other of those resources provided by a cloud service provider. And there are different styles of cloud computing available in these 3 broad categories of infrastructure as a service, platform as a service, and software as a service. Starting with infrastructure as a service, and what is being provided by the cloud service provider in that case are the basic facilities. You're effectively renting servers, storage, networking capabilities, and usually virtualization. But all the software that then goes on that, often the operating system, certainly the middleware, the runtimes, the application, and the data, all that's down to you as the customer to install, configure, and manage. By contrast, right down at the right-hand side of things is software as a service, where effectively you're renting from the cloud service provider some complete application, does whatever you want it to. Now, in that case, there's this complete concept that the whole system is the responsibility of the provider. So everything from the basic hardware resources right to the operating system, the middleware stacks, and the application code, all of that is the responsibility of the provider. They have to stand it up, they have to manage it. They're completely responsible. Now, software service is great as long as the applications do exactly what you want them to do. But of course, it is typical that as an organization, you're going to need some software that is customized, that is doing the job that you wanted to do, and you won't find in software service every application you ever wanted, unfortunately. It'd be nice if it were available that way. So in the middle, between infrastructure service and software services, developed this perhaps most dynamic area of cloud computing these days called platform as a service. And on the one hand, it allows you to build and to run custom applications, one suited for your organization, does what you wanted to do. On the other hand, it avoids you having to stand up and manage and operate the whole of the software stack the operating systems, the middleware, the runtimes, all these things that are necessary for your application code to run, but which can be oftentimes complex to set up, difficult to configure, difficult often to find the skills required to do all of that work. So Platform as a Service is going to provide all those capabilities from the provider. The provider will stand up the middleware, stand up the runtime, configure it, operate it, and you as the customer, all you have to worry about is putting your application code in there and putting your data in there, and then your application will run. And the whole idea here is to simplify the whole task of building custom applications and of running them, making it much easier than it would be on premises or even with infrastructure as a service. Another thing we're finding is that appealing those software as a services as an offering, great when you can get applications off the shelf, in many cases customers find that they need to do small customization, small tweaks to the capabilities of a software as a service application in order to get the best out of it. And it has become a commonplace now for customers to build these small customizing components using a platform and service offering, connecting to the software as a service application through some kind of API. And more of the software as a service applications are providing these APIs to allow that customization to be done. And all this is about getting the capabilities that you need up and running as quickly as possible. Okay, if we could move to the next slide, please. Now, as well as the capabilities being provided by Platform as a Service, there are some other factors that need to be thought about. Now, there are different styles of cloud computing, different ways of deploying your applications, and the broad division is between public cloud computing and private cloud computing. Now, public cloud computing is where everything is run in data center belonging to the cloud service provider. It's not on your premises, it's on the provider's premises. And with a public cloud, it's also typically true that your applications are sitting alongside the applications of many other cloud service customers. That sharing element of cloud computing is essential to its economics, effectively. That's how cloud computing can be very cost effective, because you're sharing resources with other customers. So that's public cloud computing. The alternative is one or other form of private cloud computing, where the resources being used by your applications are dedicated to you. So that can be on the premises of a cloud service provider. There may be a dedicated environment where the machines, the networks, and so on that are being used are only being used by you as the customer. They're fenced off from any other customers. That will be one form of cloud computing. The other form of private cloud computing is where you run the cloud system yourself inside your own data center, inside your own organization's data center. And there may be very good reasons for doing it that way, which we'll come on to later. But one other factor that usually comes into play when you're building new cloud applications, such as the ones we can do with a PaaS, is that you need to connect with existing enterprise systems. Most organizations have those existing systems. And then you need to connect any new cloud-based applications that you're developing with those traditional IT resources, those existing applications, the existing databases that you have on premises. And the term that's used for connecting private public cloud are all to do with what's called hybrid cloud, a combination of different elements that have to be used together to produce the solution you're trying to work with. Okay, if we could move on, Tracy, to the next slide. So let's touch then on the characteristics of platform as a service environments. And I'd like to show that on this 12-sided star here. So if we start near the top, the fundamentals of the platform as a service offering is they're there to support custom applications that you're developing for use in your organization. Now, you may develop the applications yourselves inside your organization, or you may acquire them from some third party, doesn't matter which, but the PaaS becomes the environment in which you are going to run those applications. So moving around clockwise from the top, the first important feature of a PaaS, it's going to have to support appropriate runtime environments for your applications. So we're talking about, say, the Java JDK, if you're your Java application, or the Node.js runtime if you're developing a Node.js application, or the PHP runtime if you're using PHP. And it is an interesting characteristic of many PaaS systems that they tend to support multiple runtime environments at the same time, sometimes called polyglot environments. That's a curious term that's used to describe those. And basically it means that the PaaS can support the most appropriate technology for your application. And you may find that some applications are better using one technology and other applications are better done using a different technology. These PaaS environments allow you the flexibility to do that. You're not stuck with one runtime. Moving on round, the PaaS typically contains facility for rapid deployment of your application. So in the past, it could take hours, days, sometimes even weeks, and in some customers I've seen to deploy an application into production. PaaS environments are there to do it in minutes or seconds in some cases. So very rapid deployment of applications into runtime. Next, we have the middleware capabilities. We said in the first overview diagram that one of the important features of a PaaS is to provide the various middleware stacks that your application code is going to depend on. You don't have to install them, you don't have to run them. They are provided by the PaaS environment itself. And of course, there may be different forms of middleware that you may want to use, whether it's an application server or some messaging infrastructure, whatever it is. Those various facilities are usually there in the PaaS environment. Another feature of a PaaS environment is it will provide typically a whole range of services which will be used by your application. And the whole idea here is that the services provide capabilities to your application that then you don't have to write as part of your application. It's about cutting down the amount of code you have to write, getting your application into production quicker than otherwise. Another useful feature of PaaS environments is that they're typically providing all the various capabilities they do in a pre-configured way. In infrastructure as a service, cloud services, it's often the case that when you come to use them, you end up as the user having to configure all kinds of facilities to make it do what you want it to do before it will work. The PaaS environment takes a very different approach where it basically provides a pre-canned, pre-configured environment that's guaranteed to work. And again, cutting down the amount of time it takes to get your application up there running and usable. Another capability that you would tend to find in many PaaS systems is what's termed API management. And this is controlling what interfaces are provided by your application to external applications, maybe to a mobile application, for example, or to a sophisticated web front-end application. Controlling which API is available to which users is a very important feature, both from a security point of view and also for differentiating between different kinds of users. And API management capabilities are a very useful way of doing that. No system is usable unless it's secure. So it's unsurprising to find a whole series of security capabilities will be provided by the platform as a service environment. This then says that some of those capabilities don't have to be supplied directly by your application. The environment, the system itself will provide them for you. We'll look at some of those in more detail later. Platform as a service is about developing and then deploying custom applications. So it's not surprising to find that the PaaS systems typically contain a variety of developer tools that help the developers of these applications build, test, and then deploy the applications that they're working on. But as well as development tools, there are also operations capabilities, because a PaaS environment is not only about developing stuff, it's about running it in production afterwards. And so PaaS environments tend to have a series of operations capabilities that allow the applications that are running to be managed, to be controlled, monitored, and for things like updates and so on. And we may find also that as well as developing completely new applications for the PaaS environment, you may find tools that help you port existing applications from, say, an on-premises environment into the new PaaS cloud environment. The facilities available don't necessarily mean that you'll avoid having to recode your application to some extent, because a cloud environment can be very different to an on-premises environment, but the porting facilities can help you with the first steps. And last but not least is the fact that many of these platforms as service environments are really aiming in the first instance at what we might call systems of engagement. In other words, applications that are designed to help the lives of end users, stuff like mobile apps, stuff like web apps. And the facilities provided by PaaS are particularly oriented towards that kind of application. Okay, so those are the various characteristics that you're likely to find in a platform as a service environment. If we can move on, Tracy, to the next slide. One of the important things to think about if you're going to use a PaaS platform in your organization for the first time is that you need to think about it from the high level of governance and business considerations. If you're going to introduce platform as a service, we suggest that you create a cross-functional team right across the business, involving not just the IT department, but the end user departments, the departments that need the capabilities, say, for their customers or for their staff, whatever is involved. You need to look very carefully at the cloud service agreement that's offered with the PaaS environment. You need to make sure that it's going to do what you hope it will do. You need to think about the information security and risk management that you need to have in place. Clearly, you need to look at costs and charges. Cloud service environments have their own have their own cost environment, and you need to understand your application and its likely costs based on the pricing plans that the provider has available. On the governance side, you need to worry about things like having a clear communication path between your organization and the provider, particularly when it comes to change management, because in many cases, changes will be done by the cloud service provider, and they may be doing it on a regular basis. You will not necessarily have control over all of the elements of the system. You want to know from the provider when changes are going to be made so that you can plan and deal with them appropriately. You need to be sure that all the right security controls are in place for handling your applications and your data. You need to understand where processing is going to take place and where data might be held. That can be a big issue. We've seen in recent days the brouhaha about the European Union Safe Harbor program being ruled illegal. That's all about knowing where your data is and that appropriate data controls are put in place for the data and for the processing you're handling. And last but not least, your governance should very much consider what will it take to move away from the particular platforms and server environment that you've selected. Have you got an exit process in place? Moving on to next slide, please, Tracy. So this slide really introduces the section of the guide that deals with information and guidance to acquiring and using platforms and service offerings. And we have a number of areas which are listed with these bullets down towards the bottom left of this slide. And these in turn will help you understand things like what sort of application architecture is involved in the typical PaaS offering. issues like security and integration, and then issues of tooling, process methodology, and how you go about deploying and running applications with a PaaS. And there's an interesting quote here from Sam Ramji, the Cloud Foundry Foundation, and as he says, you must make application developers more productive in order for your businesses to be in business, and that is where PaaS fits. It's about supporting the economic pressure for the need to develop more and better software, because ultimately your business is implemented through software. Most businesses couldn't live without their software today. So PaaS is all about addressing this issue and making it faster and better for your business, for your organization. If we could move on to the next slide, Tracy. Now, the end-to-end application architecture that's typically used in a platform as a service environment may be something that's going to be new to you. And there is a approach and methodology that's called the 12-factor app, which underlies many of the PaaS platforms, which explains why they're structured in the way they are, why they have the particular facilities they do. And you can find out about the 12-factor app application architecture and approach to developing applications by the URL here, http:12factor.net, that's down at the bottom right on this page. That then is summarized on this chart. What is a 12-factor app? Well, there are a number of points, 12 points, that make this up. We start with the code base. The concept of 12-factor is basically to have a common code base in a repository and managed that's used for all the development and production work that we're going to do. Secondly, we have the question of dependencies, that all the dependencies that your application code has to be explicit and managed. There shouldn't be anything buried inside the code. We want to see all the dependencies up front and outside so they can be handled and managed appropriately. The third item is to separate out configuration. Configuration shouldn't be part of the code base. Configuration is something that's applied and may be done differently for different kinds of deployment of the code. So, for example, we would absolutely expect a development configuration to be different to a production configuration. But again, you have to have a single code base and then externally having the configuration, applying that as part of the process of either doing development, doing testing, doing production is an important feature. Another part of the 12-factor app is the idea of developing our application with a series of backing services, so that there are services used by your application to do important pieces of what your code is doing. We'll look at that in more detail. One of the other features is the whole separation of the processing of building, of releasing the code, and then running it. Separate processes for those, ideally automated, ideally with appropriate testing and validation steps before you go from one phase to another. The 6th point is the concept of building an app as a series of stateless processes. We'll come on to that later, but this is an important way of getting the best out of the cloud computing environment, and in particular scalability, allowing your application to smoothly scale up from handling a very small number of transactions to handling loads of transactions very smoothly. Point number 7 in the 12-factor app is the idea of having separated port binding. Don't, in other words, burn in endpoints, addresses, ports, that kind of thing into your code. Have that applied separately from the outside, and many of the PaaS environments do that explicitly. Don't even let you set particular ports. You're actually told which port you're going to use, because the overall environment is managing that, not your application. There's the idea of using heavy amounts of concurrency in the way in which you build your apps. So the way of handling a lot of load is effectively to handle each of the requests concurrently, maybe on separate processes, separate instances of your app running in parallel. So that's another way of getting the best out of this cloud computing environment. There's the concept of disposability, the ability to stop a process and get rid of it without causing damage. That's associated with point number 6 of the stateless processes. If there were state and one of the instances stopped, you may have lost something. If the apps are stateless and they fall over for some reason, then they are disposable. Nothing particular has been lost. Factor number 10 is the idea of having parity between development environments and production environments. One of the major problems in traditional application development is that the development environment isn't even close to what is actually being used in production. And all kinds of hassle happen when the developers hand over the code to the operations guys who then put it in production, only to find that it may not work for some reason because there are differences between the production environment and the development environment. And so it's common to find the ability in a PaaS system to do development and production using exactly the same basic configuration, same sets of services, same configuration of middleware. They're not the same, but they are closely parallel, so there's very little difference when the code is taken out of the development environment and put into production. There's the treatment of event logs as event streams, not just files, but streams of data that can be taken places and which can be managed. And a very simple example of that is if you have, 3 or 4 instances of your application running in parallel, ideally you want to be able to manage all those instances at the same time. So far better to stream off the data to some common logging process that can then analyze and provide useful information to the operations folks. So logs are not files, think of them as event streams. And last but not least is the idea to separate out any administration processes and effectively try to make them into automated steps. Automation is one of the big features of these environments, and it's an important feature of making development quicker and more reliable. So the 12-factor app, this is what's underlying many of the PaaS systems that we see today. So if we could move on, Tracy, to the next slide. Now, another thing that turns up in many PaaS systems is the concept of using containers to run applications. So I'll start with perhaps something that's more familiar, the idea of sharing a system by having many applications running each in its own virtual machine. So a virtual machine is a particular way of sharing a system to be used by these different applications. And this idea of sharing is fundamental to the idea of cloud computing. We're going to have, even if it's a private cloud, we're going to share systems by running multiple of our applications on those same systems. Now, it's common, though, in PaaS environments to not so much use VM environments, but to use containers. Containers are similar idea to a VM, but instead of virtualizing the basic system itself, the hardware, which is what happens with a VM, a hypervisor, what instead happens with a container is it's virtualizing the operating system. And what that means then is that the code inside the container is everything above the operating system. It doesn't need a copy of the operating system because it's going to use the host operating system for those purposes. So as a result, what is in a container is only the app and maybe its dependent software stack it has to use. The operating system isn't there. So that means that containers are more efficient at sharing the hardware. They're lighter weight, they contain less code, they take less time to start, they take less time to stop because there's less to do. And this has been taken advantage of by many of the PaaS platforms such as Cloud Foundry and Heroku and so on, to make it faster to start applications and indeed stop them, and also to have more instances of an application running on a given system. So pack things in, get more out of the hardware. It's useful to understand this then because you find that you are being encouraged to package your application in the container format and run them using containers. One other very important development, of course, in more recent times is the development of the Docker container technology. And there's actually an open containers, open source project into which Docker has been placed that is generalizing Docker for more environments. And we're seeing many PaaS platforms committing to going with that open containers project as the way of handling containers in the future. So containers, very important way of running your application. If we could move on to the next slide, please. Okay, so we talked a little bit earlier of using services and indeed microservices. Now this is one of the ways of architecting an application that's encouraged by typical platforms of service offerings. Start at the top with the application. The idea of microservices is to divide down your application into a series of separate processes called microservices, which can be deployed and operated independently of each other. So in the example in the diagram here, we've got an application which has been broken into three, the main application and microservice 1, microservice 2. And the reasons for doing this are, firstly, we can scale up or scale down each of the components independently. So in the past, we may have found what we call monolithic applications running, say, on an application server where the whole thing was one big lump that was all deployed in one go. And then in order to scale it up, in order to deal with, say, higher load on our application, we have to scale the whole lump, the whole application, all of it at once. And that can mean that we're scaling up parts of the application that are not actually being stressed, and so it's inefficient. This way, this microservice approach, each of the components of the application can be scaled up or down independently, and so get us more efficient usage of our resources. In addition, we can have different update cycles for the different components of the application. So if microservice 1 is more slowly developing, there's less change involved in there, fine, we don't have to update it. Whereas if, say, the main application itself is adding new features all the time, we can update that on a more frequent basis. Now that's the organization of the application itself. The other big idea behind platform as a service offerings is the availability of a whole series of services which are being provided by the cloud service provider. They're run, installed and run and made available by the provider. So when you want one for your application, all you have to do is sign up for it. Say, I want a new instance of a database or a Twitter feed or a video service, whatever it is that I want, and then that's available to your application. And the whole idea of these services is to cut down the amount of code you write, simply invoke these services. So one of the big things you will find in many PaaS offerings is a big services catalog containing all of these kind of services. And in some cases, like some of the analytics services, writing all of that stuff yourself will be a huge task, and you're now able to get very sophisticated pieces of code off the shelf, ready running, configured and available to you. And all you do is have to call an API, and it's available in your application. Moving on to the next slide. Here we start looking at the questions of how you might go about integrating the application you're developing and running in the PaaS environment with existing applications, existing data, existing systems that are running in-house in your existing enterprise data center. It's commonly the case that you'll need to do some levels of integration. It's fairly rare to write a completely new standalone PaaS application. It happens sometimes, it's not common in my experience. So there are various ways in which PaaS systems provide for connectivity of this type. One typical approach is to provide an API management module that you install to connect into your enterprise data center, and which then links to the various enterprise applications that you have, or sometimes directly the databases you have, and expose their capabilities using a new API that you develop, and which is then usable by the PaaS application. Now, the API management may be just more than simply exposing existing stuff. There may be a need to do things like data transformations to convert the existing formats of enterprise data into a format that's more easily consumable by the PaaS application. That can be particularly the case where the PaaS application is supporting, say, a mobile app, and we may need data in, say, JSON format in the PaaS application for what we're doing, but coming out of the enterprise database, it may be, you know, an SQL query, and it may be coming back as XML or some other structured data format. And so we may need the API management layer to do conversions as well as simply mapping. Another approach, which is more commonly used for mapping data from inside the enterprise to a database that's existing in the PaaS system, is the secure connector. And that can allow for batch copying of data between the enterprise environment and the PaaS environment, or for dynamic fetching of data on demand. But the idea here is that it is commonly the case that enterprise data stores and enterprise systems can't cope with the transaction rates and don't have the data in an appropriate form for the PaaS applications to use. So it's often commonly the case that the PaaS system uses, say, a NoSQL database with JSON data or a graph database, whatever's most convenient, and the data has to be transformed into that environment from the enterprise data center. And the secure connector can be a way of assisting getting that transformation done. If we can move on to the next slide, please. We always have to consider security as part of our operations, whether on premises or in cloud computing. And of course, that is very much the case for platform as a service. What you will find in typical PaaS platforms, there will be various tools, facilities that help the developers build secure applications and services. That's one thing. So that's the stuff you're creating. It has to be secure, and you need some tools and facilities that will help you out to do that. So you may find, you know, things like code analyzers that will look for vulnerabilities. You may have testing tools that can do vulnerability testing on endpoints that you expose, and so on, all there to help the developer. The second set of stuff that you may find in a PaaS environment is then sets of services and sets of capabilities provided off the shelf that help you secure your applications and services. So it's not untypical to find firewalls automatically provided as part of the PaaS environment, but we may have secure databases, we may have encryption management facilities, including key management, all these provided as off-the-shelf services which are built into the PaaS. I'd like to bring your attention, though, to all the issues of security, which are actually dealt with in quite a comprehensive way in another white paper that CSCC published called Security for Cloud Computing. And in there you'll find the 10 steps to manage cloud security. And there's a link on the bottom right of the slide here which will get you to that paper. So for the in-depth stuff on security, it's worth having a read of that paper. Moving on to slide 14, please. Then we have development tools. There's some variety, I think, in what you get from different PaaS environments, but it's not untypical to find the kind of tools being offered that are shown on this page. I've tried to color them in a little differently to separate out the different pieces. It's common to find code editors as part of the offering. Often they'd be cloud-based ones handled through a browser, using, for example, things like the Eclipse Orion framework, which is a cloud-based code editing facility. You'll very commonly find a code repository, say a Git repository for holding your code and sharing it amongst people in your project. And associated with that will be a set of build tools, both open source and custom in some case, for building the code and running it through a test sequence. So the build tools, unsurprisingly, usually linked to a test environment of some kind, and the test environment commonly has some set of debug facilities that allow you to work out what your application is doing when things don't go as you expect. And it's getting more common to have those remote debug facilities so that you can be sitting in front of your workstation and debugging an application that's running up there in the cloud PaaS environment and debug it real time. There are also then sets of test tools that you'll find available. We may find a series of security analyzers looking at your code for vulnerabilities that you don't want to have. And then there are things like load testers that help you test your application to see how it behaves under stress, that doesn't fall over, that it continues to be available. Now, those may be all built into the PaaS environment, but of course we know that developers have their favorites and may prefer to have workstation-based tools, either command line or GUI type tools. Those external tools can often be plugged into these PaaS environments through a set of development APIs that the PaaS makes available. It's important to look out in the PaaS for those to be available because you want to be sure that the tools that your developers are most comfortable with can plug in and can be used with the PaaS environment you're going to use. Moving on to the next slide. With a PaaS, you should absolutely expect support for Agile development and for DevOps processes, where we try to bring together as much as possible the developers and the operations guys into one seamless operation from developing the code to having it running. We should expect there to be support for test-driven development. That's pretty well essential for Agile to be able to go rapidly from developing code to having it running. We should look for rapid allocation and deallocation of resources. So, we shouldn't be looking for weeks and months to allocate stuff. It should be seconds and minutes at most. And best PaaS systems do that. We will want to be looking for high degrees of automation of all the processes, build, test, QA, deployment, all of that should be automated. Shouldn't be expected to do a lot of manual operations. The best systems, you commit the code and stuff just happens from there automatically. You don't have to, as a developer, raise a finger unless something tests your fails the test sequence. We should be looking for things like blue-green deployment. This is the idea of introducing a new version of the code alongside the previous version to look for a seamless transition and ramp up the number of instances of the new version and ramp down the number of instances of the old version in a smooth fashion. And we need operations capabilities that are going to enable for deployment and the handling of scalability of services and of applications, control over the placement of runtime instances. You may not want them all in the same data center, may want to deliberately run them in different data centers for resiliency purposes. We need to be able to manage logs, get information back, do analytics on the log information, and that's also part of the visibility of the overall service failure. We want to get alerts, monitoring, have APIs to get out that information from the system so we know what's going on. Moving on to the next slide. We talked a little bit previously about the deployment aspects. We can have deployment of a PaaS environment in a public cloud, in a private cloud, or hybrid, combining multiple of them. So we may be on premises with private, we may be using provider premises. One of the main reasons for worrying about this is whether you've got the right kind of reliability, particularly if you run on premises. Can you make it as reliable as you need to be? Will you have the right levels of skill to handle the PaaS environment? That's no trivial matter, as people have discovered. I've seen many customers who have struggled to find the right skills to enable them to have their PaaS on premises running smoothly, 24/7, because this becomes a production environment. And then the whole question of the applications, the services, the data sets you're going to use are going to be considerations. Where do you place the applications? Where do you place the data? Data may be sensitive. You may prefer to have it on premises. However, the applications are providing stuff out to the public, so the applications themselves aren't quite as sensitive. So even though they may be connecting to sensitive data, the applications themselves don't have to live in a highly secure environment. So there are a whole series of considerations here about where it's best placed. And you may decide to use multiple of these deployments. Not one deployment style will do for everything. You may put some in the public, some in the private environment. So moving on to the keys to success. There's a longer version of these in the white paper that's worth looking at. You certainly need to do a cost-benefit analysis of using a PaaS. It'll take you effort to get there, but for new applications you may find it both more cost-effective and also give you other benefits like greater capabilities because of the built-in services and faster time to market because of the agile nature of the environments. You have to worry about your security risks versus the innovation that you need to do. So you need to think about that. You have to look at the value offered by a particular service provider, one particular PaaS offering versus another. They're not all the same. They have different pricing. They have different capabilities. It's worth spending some time looking at some alternatives and checking out which ones are most suited to your needs. You have to worry about the long-term viability of the PaaS provider ecosystem. So you have to think about whether they're going to be around next year and 5 years' time. Particularly look for a well-supported ecosystem. Some of the open source environments have dozens and dozens of major organizations supporting them, for example. You need to think about portability, both in terms of lock-in to a particular provider and also about the ability to change your deployment model as your needs change. And you think about the integration between the PaaS environment and your on-premises stuff, and you need to make it as simple and straightforward and secure as possible. And you need to consider what it takes to move to Agile methods and DevOps processes if you're not there today. Moving on to what is basically the last slide. Here are some examples of PaaS offerings. We have these listed in the white paper, but in addition in the white paper there is a link to a very handy website that actually lists almost all the PaaS offerings available today, which is a much bigger list than is shown on this slide. And that can be a very valuable web resource for learning more about what's available in the marketplace. But here we have some of the major offerings, some of the ones that's available as PaaS cloud services offered by a provider, things like IBM Bluemix, Google App Engine, Microsoft Azure, Red Hat OpenShift, and so on. And at the bottom, some PaaS software. If you wanted to install and run your own PaaS, here's some PaaS software you can go and get and do that. Cloud Foundry, Red Hat OpenShift, and the Windows Azure Pack. So alternatives, either buying it as a service off the shelf in the top set or installing it on your systems and running it yourself on the bottom. So to round off then, for the last slide, we'd love you to join the CSCC and help contribute to white papers such as this one on PaaS systems. That's very easy to do. It's free and very easy. There's a link here on the page on the Cloud Council website to do that. And we'd love to speak with you on one or other of the working groups to work on white papers like this. And you can find all the material that the Cloud Council has ever produced on the web link at the bottom. There's a resource hub down there, and the white paper we've been talking about, and lots of other white papers are all to be found there. So thank you, and I'd like now to hand back to Tracy and any questions you may have.
Thank you, Mike. It was a very good presentation. We did get some questions in. Just one second. The little toolbar disappeared here. Hold on one moment. There we go. Let's back up. Looks like we have a couple minutes. Okay, the first question. How easy is it to integrate a PaaS application with existing enterprise applications?
Yeah, that's kind of a bit of a how long's a piece of string type of question in a way. It obviously depends on what kind of enterprise systems you've got to connect to, and they can vary enormously. But there are tools available which you can buy that help ease that process but you certainly got to think about what capabilities of your existing systems you're going to need in your PaaS environment, and effectively produce an interface into those existing systems that gives you what you need. And it may be a fairly short process to do that, or it may take a lot more effort, depending on what the nature of the enterprise system is. But it's being done successfully in many installations now, and as I say, there are good tools available to help you do it. I talked about them in general terms. Various companies like IBM have very specific products that help do that.
Thank you. And I believe this was slide 6, where you have the characteristics of PaaS. Is there a source for slide 6, or was that developed for the white paper?
Slide 6 was developed for the white paper. So those characteristics are our assessment of what you find in PaaS. There's no source other than the white paper that I'm aware of that has this particular grouping.
Okay, thanks. Let's see. There's a question here about are there any specific data integration limitations in PaaS?
Not that I'm aware of is a simple response to that question. Firstly, it's common for PaaS environments to support a whole series of different data services. So it's common to find, for example, traditional SQL-style databases, no SQL databases, graph databases, and some of the latest stuff. So you'll find in the PaaS environment a whole series of things like that. And then if you need to integrate, of course, with existing enterprise stuff, then we've already talked to some extent about that. And you can use various forms of connector or API management solution to get through to your existing data in your enterprise. So I think PaaS environments are pretty good at handling data.
Thanks, Mike. And then we have a question asking if you're suggesting that the hypervisor is less efficient than the container approach. If you could just sort of elaborate on that a little bit.
Yeah, I mean, I think it basically is, and there have been various tests to show this. If you try to run a set of VMs on a system and then try and run a set of containers, you can actually run more containers on the same system than you can of VMs. Effectively, the thing that the hypervisor is doing is abstracting the actual hardware itself, which there's overhead in doing that, of trying to provide an abstraction of the hardware. So that each VM then above the hypervisor has to contain the OS. The OS thinks it's operating with a piece of hardware underneath it. In fact, it's talking to the hypervisor, and that's managing stuff. Now, with the container approach, you're not attempting to do that at all. You're just saying we're going to share this operating system, but in a controlled way. So the container approach is effectively using the operating system that is just doing it in a clever way that keeps the processes in each container separated out from each other. So it's a much lighter weight approach. You don't have the kind of overhead that the hypervisor has in abstracting the hardware, and there's literally less code running because you don't have copies of guest operating systems inside each container. They're just not there. So it is a lighter weight approach. That's why there's so much fuss about Docker, for example. And Docker's certainly been a big thing in the industry over the last year or so, because it is this lighter weight container approach to virtualizing applications. Okay?
Yes, perfect. And thanks so much for your time today, Mike, and also John and everyone that dialed in. So we'll post the presentation and recording this afternoon. I'd like you to visit our site at any time. It's cloud-council.org. Membership is free, and if you're interested in collaborating on future white papers, feel free to join one of our working groups. And that's it for today. I hope everyone has a great rest of the day, and thank you.